Okay. Yeah. So for the homework, basically you want to know the shortest path for breadth first search and depth first search. So yeah, for breadth first search, I made for you in the coding an array that has the following structure.
Right. It's the frontier distance step with the step plus 1 and then the column, right?
Yes. Frontier and distance from the start, step, exploration step. And this guy here will be parent. Okay? And you will do with this parent at the end, just like what I have done with you few moments ago in Dijkstra's algorithm. We trace the parent from the goal to the start.
Right.
Okay? So I will just give you a brief one step here. So S, I will explore this. So we have first this starting node S, distance is whatever, step is just any numbers, infinite, for example, -1, zeros, something like this. Then from S we explore 4 cells. 1, 2, 3, 4. Add them here. 1, 2, 3, 4. All of them has distance of 1. I think this is clear why it's 1. Right, Johnny?
Yes. Yes.
You know, good. But the steps is different. It's 1, 2, 3, 4. Okay?
For the frontier,
Explore this first, then
is it supposed to be the node ID?
Yes, of course, but since it will be confusing for you to write the real node ID, which is 1, 2, 3, 4, 5, 6, 7, 8, 9,
Oh,
10.
right.
So this will be actually 17. Okay, so this should be 17.
Right.
This should be you want it's 26. This should be, I'm sorry, this should be 26. And this should be 27. The start, and this should be 37, and this should be 28. I'm very sorry, 28. Okay, but it will be confusing for you. So
Yeah.
let's call just between us. But in the coding, it will be those guys. Okay.
Right.
The distance is 1. This is clear. The step is 1, 2, 3, 4 because I discovered this and this and this and this. I'm sorry. Right. This should be 3. So assume here it's up, right,
and
down, left.
Yeah.
Yeah, that's fine. This is up to you.
Right.
Then the parent here is the node that discovered those new nodes. What is the node that discovered this new node? It's actually the starting node, which is, in that case, should be 27. Okay? Then you take, for example, this guy. This is your frontier now. So then 5, up, right, 6, 7. 5, 6, 7. Step will be 2. I'm sorry, the distance is 2. The step is 5, 6, 7.
Right.
The parent is 1, which is 26. Okay. Okay. And that's it. Until you go to the goal node, then you trace back the parent. What is the parent of the goal node? For example, whatever, X. What is the parent of X? It's Y. What is the parent of Y? It's K. until what is the parent of M? It is the starting node. Then this will be the shortest path. Okay, it will be something like this: G, X, Y, K until you reach MS, whatever. Okay, that's for breadth first search. Okay, now for depth first search, you can't do that. For depth first, you can't do that. You should do another. Should do another one, another stuff. So with breadth first search, okay, so let's assume the G is the goal is actually here. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. At 8, we explore up, not valid, left not valid, down not valid. This is actually my parent, so not valid, visited. So we'll pop this out. Then we go back to 7, 7 we discover the goal. So these nodes here, those nodes, that are marked with yellow, you can find, I don't know how to give a good terminology for this, but between us, shortest path. Although it's not guaranteed to be shortest path. What
Right.
is the shortest possible path between the discovered node? Let's call it in that. The distance to the start node. And choose the neighbor with, so you start by the goal node, check its neighbors, okay, until you find the neighbor that has the minimum distance to the start node. So start with goal, find a neighbor to the goal node with minimum distance to the start node. So this is the goal. It has 4 neighbors. This guy is not valid. This guy here, it's an empty cell, but it's not explored, so we can't use it. This neighbor here, it's explored, good, but it's distant to the goal distance is equal to 6. And this guy has a distance equal to 7, so we'll exclude that. Then the last neighbor we have is this guy to the goal, which has a distance of 5. Good. So in the next iteration, we start with this guy and check its neighbors. And choose the neighbor with the minimum distance to the starting node. It will be that one. Then we check the neighbors of that guy. Okay, it has 4 neighbors. This guy, both are not valid because Hello?
Yes,
So I'm
Mr.
very
Duaa.
sorry something happened. I don't know what happened and everything. So let's go back. If you
Yeah.
wanna guys wanna leave, just let me know. That's very fine. Should I continue or
Uh,
okay? So we stopped at. Do you see my screen or
yes, I can see it.
you see my screen, right? Good. So I ended up with this node, or node 4. It
It's
has
just that
again 4 neighbors. What?
it's weird because you kind of like cut off at some parts, and um, I'm not sure why that is.
At which part?
Yeah, like your video cuts off for like maybe a second or two, and then you know, it fixes itself. I don't know if it's a connection issue or uh,
I don't know. I don't know. Anyways, that's fine. So so assume that the goal is actually here. So 6, 7, 5, 6, 7, 8, and this is the goal. And this is just node 5. Okay. If you studied depth first search, you will find yourself excluding this out of the stack. So this is not ours now. And you have these nodes right now. These are the nodes that you discovered or explored inside the map.
right,
Start 1, 2, 3, 4, 5, 6, 7, 8. Okay. What we're gonna do, we take node by node from the goal until we reach the start. Take nodes or make while true, something like this. Set a variable called node equal to goal and make while node doesn't equal or not equal. It's a pseudocode, so we can use better annotation. doesn't equal start. Okay. So goal now, the node now equal to goal, the goal node. Then we make a for loop over the 4 neighbors of that node, which is currently the goal. Okay. Skip between the 4 neighbors, choose the node with minimum distance to the start node. Okay. So let's call it node min, for example, something like this. So in this for loop, you discovered the node with minimum distance to the start. So you assign now node equal to node min. And then you continue the while loop. So let's do let's track this algorithm, this short algorithm with the map that we have here. We first start by the goal node, okay? So node now equal to the goal node, equal to this one. We check the 4 neighbors of the goal node, and we choose the one with minimum distance to the start. What are the 4 neighbors of the goal node? This one, this one, this one, and this one.
Right.
This one is excluded because it's a wall. This one will be also excluded because it's not an explored, it must be an explored cell. We end up with 2 other candidates, 5 and 7. Which one has minimum distance to the start?
It would be 5.
Right. So from this for loop, node minimum will be 5. So I will set node now. So node in the beginning is equal to goal. Now it will be equal to 5. So now our node is 5, and we continue the for loop. 5 has 4 neighbors. It has this one, this one, this one, and this one. This is a wall. Okay. And this one, you remember, this is the one that we came from. So it's better here to make a kind of, list, which you call, for example, previous nodes, the previous values of this guy. Okay. To exclude, because if you didn't do that, so you will just go from goal to 5, from 5 to goal, goal from 5, from 5 to goal. Okay. It will be an infinite loop. So also this will be excluded. This will be excluded. Now we end up with 6 and 4. Which one has the minimum distance to the start? 6 or 4?
It would be 4.
You answer. 4. Good. So node minimum now will be 4. And node will be 4. And we go in the while loop. Is 4 equal to start? No. So we're gonna do these steps again. 4 has 4 neighbors. 5, this guy, this guy, this guy. These 2
are not
has,
explored.
that's right. So will be excluded.
Right.
Now 5 and 3, again, the same problem with 5. You keep something to say that this was a previous, aberrant, or so. I don't know how to call it. Okay, but this was one of the values of that node has taken, so exclude it. Otherwise, you will end up going from 4 to 5, from 5 to 4, from 4 to 5, from 5 to 4. Infinite loop. You will not reach the start at all. Okay. So the last option is now is 3. Okay. That's good. Even if you make just a comparison, blind comparison, the distance is we are interested in the one with the minimum distance, and we said that this node and this node is excluded, and we have 3 and 5. 3 has minimum distance than 5 to the start, so we are all good. That's fine.
Right.
Okay. And so now node will be equal to 3. 3 has 4 neighbors. This one, this one, this one, and this one. These are excluded, not explored. So 2 and 4. 2 has minimum distance to the start, so we go to 2. We do the loop again. 4. This has a distance of 3. This has distance of 1, so we take this one. So now this has 4 neighbors, and this is excluded, and this is the start. Just break the loop. Or you can compare. This has a distance of 2, this has a distance of 0. So we will take the minimum, which is 0. And now node will be equal to start node. And when we make the check at the y equal to start, yes, it's equal to start, so don't continue. And you have here the route. Okay, that's it. Any other question?
Well, it's just that I think I understand the concept, but it's kind of hard to put it into code.
No, believe me. Did you code in MATLAB before?
Well, it's actually, I'm kind of new to it. I haven't really coded
That's
in
fine.
MATLAB.
Look, MATLAB, whatever your answer is. let's you assume that you didn't code with it. It's the first time to know that there is something called MATLAB. Okay, so MATLAB, as I said before, what I call default language. So any engineer, not just electrical or computer engineer, any engineer should know MATLAB. Okay, it's really simple to code with MATLAB. Okay, especially arrays, and it's actually made as it was, I think, a senior project for undergraduate students. So some guy somewhere, okay, we want to make a language that is really, very very easy to handle arrays and matrices. Okay, right. So they came up with MATLAB. Then they commercialize, they patent it, I commercialize it, make a company, startup, and become MATLAB from that point forward. And why it should have a license, because it's easy, so everybody want to use. So it's not free. Okay, you want to have short time to code because it's easy to code using MATLAB. Then buy our license, and we have it for free here in CSUB. So as I said, it's a default language. If you didn't, you should. Okay, because if you're gonna go to a company that has a MATLAB, this is advantage for you. Okay. Again, write your code in pseudocode, something like this: steps, lines, English. Then how to Google, how to do whatever in MATLAB, and you will find it, I'm sure.
So I just want to go through the code that you have right now on the screen. So is the node supposed to equal like a subscript? Goal is equal to like some subscript, which is like some row and column?
No. Okay, you can express, but it will be difficult. You can express. Okay, let's have an example. Let's say I wanna deal with this node, for example. I have two ways. The basic way I know, and I'm sure the default and basic way is that it is the one that you just mentioned. If this array is called map, for example, then if I want to refer to this particular location, which is row 9 and the column 4, I'm sorry. So I want to say map of row 9 and column 4, okay? But there is an easier way to do that, which is using the ID of the node. It's just one number, okay? And in MATLAB, how to do that? It's very, very easy, okay? Just write, so when is the ID of that guy. So we're gonna just write ID equal to, let's call it ID, so call it whatever, call it Johnny, that's fine, okay? So this will be equal to subscript to index of, we should here put the column, the number of rows, and the number of columns of this array, and the row number, which is 9, and the column number, which is 4 for that particular cell. Let's say you want something more general, okay? So you see this one here, which is, it's really bad to know. I don't want to, to deal with, again, row and column. So it's basically, we do it in that way in MATLAB. We will write here something more smart, size of map. If you write size of map in MATLAB, it will return to you a vector, something like this, which has 10 rows and 5 columns, which was our originally entry here. The number of rows in this array and the number of columns in this array.
Right, and that's the size of that entire map, right? Or
the size of the entire map is, what is the size of this array? It's 10 by 5, right?
Right.
We write the size in MATLAB as the vector. The first entry, the first element is the number of rows, which is 10. The second entry is the number of columns, which is 5.
Right.
We don't write it 50.
Right.
Because if you write it 50, it may be 5 by 10 or 10 by 5, right? So we must mention to MATLAB the number of columns and the number of rows. Because if you write it as a number, 10 by 5, which is 50, MATLAB will, it will be ambiguous for MATLAB. Is it 10 by 5 or 5 by 10?
Right.
Right? So you must write it as rows, columns, as a vector. MATLAB should know exactly the number of rows and the number of columns. And this function size of map here will return this vector. It's exactly, this is exactly equal to, if you write it in that way, sub to index, I'm sorry, 10 and 5. I'm sorry, 10 and 5. 10, 5. This is row 9 and column 4. This is equivalent to sub, I'm writing it again to be more clear, 9, 4. This is equal to this.
Right. So you're looking into that array on row 9 and column 4 in order to find like the index of that cell. That's what it's doing there.
No, what I'm saying is something different. What I'm saying is that if you wanna, there is something in here, some value.
Right.
Okay. A map usually have a value here. So we wanna refer to this location. we have two ways to refer to it. Either to write map of 9 and 5. This will give us the value there. Let's call it x, 5, 7, whatever. Or we can write it like this way: map of ID. Both are the same. And what's ID? ID is equal to sub to index this thing. Let's say you want to put 5 here. You want to put in that cell 5 in that array. Forget about depth first search, width first search. Forget about all of this. You have an array, and you wanna, this array is 10 by 5, and you wanna put in that particular location 5. You can do it in that way. You can say that map of 1, 2, 3, 4, 5, 6, 7, 8, 8, and 1, 2 equal to 5. Right. Or you can do map of, this will be 18 equal to 5. Why 18? Because the ID of this location is 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So both are equal. You can do in that way, you can do in that way.
Okay.
Okay, guys. Any other question?
For your while loop that you have there, it says node, when node does not equal to start. That's comparing the indexes, right, of the node and the start.
That's the ID. Yes, the ID.
And then it says choosing the node with minimum distance to the start node. That's like comparing the ID from the neighbor with the start node?
No, not comparing the ID now. Comparing the distance, and the distance can be calculated in that way. Let's clear something. Let's say that you have that we are here, okay, which is really bad now because nothing is clear. Let's say we stop here, okay, and we have this node and this node, okay. So yeah, we want to compare the distance of this node to the start for node 4 to the start. Distance for node to the start, and you want to know the distance of this node, which we call 6, to the start.
Right.
Okay. So yeah. Okay, for node 4, we're gonna apply equation. This equation says that for any node, if the distance for any node to the start is equal to the absolute of n row minus s row plus absolute n column minus s column. You know what does that mean? For any node, to know its distance from the start, just have your have the column, the row and the column of that node, and subtract. Okay. Right. For node 4, okay, its row is 3, so 3, and the column or the row of S is 7, so 3 minus 7, plus the column of 4 is 3, the column of this guy also is 3, so we're gonna end up with this is 0, and this is minus 4, so absolute, so it will be 4,
Right.
For 6, this is at row 1 minus 7 again, plus column 3 again, minus column 3 again. So this is 0, 6. So where is the minimum distance here? It's 4. So we're going to take 4. And continue.
Right. So in this case, we can't do that with index, right? The index numbers, right? Like if we had like 22 minus like 21 or something, you know, like we have to have them
No,
in
no.
rows and columns, right?
Yes, we have to have it in rows and columns. That's right. So
Okay.
in that case, if you have the node ID, you should convert it back to the row and column. So whenever it's easier to use the ID, use the ID. I'm giving you, a simple rule. If you want to do everything with row and column, do everything with row and column, and just forget about the ID.
Right.
Okay.
And that while loop is going to continue the distance, or it's going to continue to calculate the distance between like each neighbor. So let's say, okay, it's going to choose the 4th one. Now it's going to run in that while loop again for.
Yeah. Yes. But now the node under interest, the node that we're gonna explore its neighbors is 4. So 4 again, now 4 has 4 neighbors. Let's change the color because it's completely messed up now. This guy, and this guy, this guy, this guy. Those are excluded. Now we have this one, which is 5, by the way, and 3.
Right.
Okay. So we're gonna, okay, let's write upon this guy here. So
Yeah, so that 4 is going to become your node, right? Where it says node is equal to node min.
what?
That node, the 4th one,
Yes.
that's going to become your new node because it's going to be equal to node min, right?
Yes, in the previous iteration. That's right.
Right. So now node is going to have a value of
Of 4.
4. And
That's
then,
right. This one will lead you to node 3, and so on until you reach the start.
and then it's going to equal to goal, right? I'm just kind of going through the code that you have there.
Yeah, until we reach the start. Here you do the opposite. You start from the goal until you reach the start goal. The start
Right.
node.
Okay.
Look at the condition here. And you start from the goal.
I see. So let's say like you continued until like node was like equal to 1. It would run once more until it equals 0, and
No, not equal 0, equal to start. There is no 0. There is no ID equal to 0 here. So in 1, you will exclude this. Then you're gonna compare the distances of these 2 equations. These 2 equations. Look. Look. You are in 1 now.
right.
This is excluded, this is excluded. So we end up with 2 to compare, this one and this one. You're gonna compare the distance from 2 to start and from start to start. This is basically 0, and this will be, if you do it, it will be 2. This will be 5 in that case. So this will be minus 2 absolute will be 2. This is 0, so 2. Which is minimum? This is the minimum.
Right.
Which is a start. So node equal to start. Then you go back to the while loop. Is not equal to don't equal to start? No, it's equal to start.
Right.
So I'm gonna break, and you know you have now the route.
I see. Okay.
Okay.
Yeah, then I'll try to figure that out to like implement this portion here in my code. Um, but I just don't get why do we use like route in our lab? What is route supposed to like indicate?
Route should be the path from the start to go. So
Oh,
route in this particular example, route should be a row or vector with values like this: start 1, 2, 3, 4, 5, then goal. I don't know. Yeah, goal. Let's call it goal. But in your code, this will be IDs. So start will be ID. So it will be, I think, 27. This is 25. This is 24, 23, 22, and 5. I am 27, 26. I'm sorry, 26, 25, 24, 23, 22. And this is 21. And this is 11. This is 12. 12. Route should be something like this for this particular example.
right.
27, 26, 25. And these are the IDs. Okay.
Yeah, because there was like a code that was saying something like length route or length parentheses route -1. I didn't really understand what that line of code meant.
Well, again, please.
There was a line of code in like a for loop, and it was saying something along the lines like length parentheses route -1. I guess that was just for uh, to show like the shortest path in gray though. I think that was just for like visuals and stuff. I don't think.
Just anything outside the two large. I said that put your code between these two lines.
Right. Right.
Okay? So just put the code there, and the code should produce a vector like this one, similar to this one. Of course, this will change based on the example.
Right.
But it could be something like this, for example, in that example. Okay.
Okay, then I think I got all my questions answered. I'll just try to attempt it, and if I need any more help, I'll definitely reach out.
Okay.
All right. Well, thank you, Professor, and have a good day.
Thank you very much, Carlos and Dominic. You have any questions, guys?
No, I was just following along with what you were doing, and it helped out a lot. I think I have an idea now as well.
Oh, thank you. Good. That's very good. Carlos, everything is nice? Okay, Carlos has maybe a problem with his mic. That's fine. Okay, Carlos, thank you. I see your chat. Okay, guys. So if you have any other question, just just ask it.
I think
Any more questions?
Well, I'm good. Thank you,
Okay.
Professor.
Yeah, I want to try doing the code, and if I have any questions, I'll email you.
Okay. Okay, guys. Thank you very much, and have a good day.
You too.
Okay.
Bye-bye.
Bye-bye.